Hello guys, uh, in this video I will walk you through the code for a data visualization project. We will analyze data and do plots to get insights for the data. So first we will install some packages, Seaborn, which is a visualization package, and Volume for map visualization package. Okay. Next we will add some packages, Numpy packages and Pandas packages for data manipulation, and then we will install Matplotlib for data visualization, and also Seaborn and Volume. We will get these packages to start do some visualization. This is the data, which is analyzing historical automobile sales data to understand the historical trends in the automobile sales during recession period. This is the recession periods till the year 2020, which is COVID-19 impact. Data descriptions is the date recession, which is 1, that means that it was a recession. 0 means that it was a normal year or normal period. Automobile sales, GDP, and also price, the average vehicle price during the period. By vehicle type, which is like super mini car, small family car, medium family car. We will understand this columns later. Okay, so right now we will get the data. We will import request, import IO, import pandas to get the data. This is the URL of the data, which is a CSV data. So we will request the data from the URL, and then we will get the data by using the bd.read underscore CSV, and this is the data to make it ready and use it with pandas or numpy packages. So let's first we imported this. Let's make sure. Then we will so this is the data. We will use a describe command to understand the data and take a look about every column, like the year column and recession column, and also columns like GDP and automobile sales. You can see that the max automobile sales with this digit and the minimum automobile sales with this digit. You can see that the standard deviation is this digit. So with the df.describe you can understand a lot of, about the data or the data frame. Okay, so this command, it will show you the columns of the data frame. df.head and then 2 brackets, it will give you like 6 rows of the data frame. So first we will develop a line chart using functionality of pandas to show how automobile sales fluctuate from year to year. Okay, so it will be a normal line chart. We will group by year, and then we will take the average automobile sales after grouping by year, and then we will make a figure with 10 to 6, which is the size of the figure. Then we will use the line plot kind line, and this is the PLT, which is for X label. We will call it years, and for Y label we will call it sales. The title of the plot we will call it automobile sales. Then PLT show to show us the plot. Here is we can see the plot, which is the years, and the automobile sales through the years. Next plot, we will do some changes. We will also group by year and automobile sales, but here we will add a range from 1980 to 2024, except 1980 to 2023. 2024 will not be included. Rotation 75 degree to make it visible in the x-axis. So this is the x-text. We will also will call the x label as we did before, years and sales, then title, and we will add a text on the graph. We will add 1981-82 it was a recession, and 1991 recession as an example of a recession periods, and to give a text on the graph. So plt.legend to show us the legend, and plt.show. Okay, so this is the text to show that this time there was a recession, and this one there is a recession. You can see that 1892, this is 1892, and we go up for like 650 to put the text. You can also do another add another text if you would like in other time periods as you wish like, and this is the range for the x-axis from 1980 to 2023. Okay, and this is the legend, plt.legend. Okay, so next we will plot a line for categories of vehicle type and analysis the trend to answer the question: is there a noticeable difference in sales trend between different vehicle types during recession period? So here we will aggregate the data only for the recession period, and then we will group by year, vehicle type, and also remove the index after doing the group by, and also we will use automobile sales dot mean. Then we will set index year. We will make the index to be the year in place equal to true. So we will group by. After that we will group by vehicle type with the automobile sales. So we will group by vehicle type, automobile sales. So we will plot also line, and X label will be years, Y label will be years, when sales trend vehicle wise during recession. Okay, so let's see the sales. So this is the lines according to every vehicle type: sports, so super mini car, and also executive car. We can see that during the recession the minimum or the lower sales would be the sports car. Okay, so we can get from this plot that we understand that during recession period the sales for sport type vehicle declined because of the high cost of the vehicle, while sales for the economical vehicles like super mini cars and small family cars increased. Okay, so here we group by year and vehicle type to get the average of the automobile sales, and then we group by vehicle type and take the automobile sales for every vehicle type. Okay, let's move on. Here we will use the Seaborn library to create a visualization to compare the sales trend per vehicle type for a recession period with non-recession period. Okay, so we will group by recession and automobile sales dot mean, and then we will reset the index. Here we will make the figure size 10 6, and then we will create a bar plot X for recession, Y for automobile sale, with the recession that will differentiate the bar with each other. Data will be new underscore df, and then X label will be recession and Y label will be automobile sales. plt.title average sales during recession and non-recession sales, so will be the average sales during recession and non-recession. This is the X text would be 0 for non-recession and 1 for the recession period. So we will do the recession sale differentiated with the recession column to differentiate the sales, one for the non-recession and one for the recession periods. So as we can see that the average automobile sales in the non-recession, of course, it's higher than the recession period. Okay. There is also another bar where we do the same, of course, with a little difference, that we will use it with the vehicle type. Okay, so we will use it with the vehicle type, and here we can see that non-recession and recession for every vehicle type, the automobile sales between the vehicle types in the different two periods. So here we will group by recession of vehicle type, and then automobile sales, and then we use this to do the bar plot. You can see that all in the recession period, we can see that the lowest automobile sales, that would be the sports car, and the also at the non-recession, the all the automobile vehicle type achieved a higher, of course, a higher automobile sales than recession periods. So from this plot we can understand that there is a drastic decline in overall sales of the automobile during recession. However, the most affected type of the vehicle is the executive car and sports car. Okay, and in this plot we will analyze the GDP for the USA vary over time during recession and non-recession period. So we will make the data for recession and for the non-recession periods. We will design the figure, and then we will create different axes for subplotting, which means we will create two figures or two plots beside each other. So for figure.add subplot, we will add one for one row and two for two column, and this ex0 will be for the first plot, ex1 will be for the second plot. Okay guys, so for the first plot we will use line plot x equal year, y equal GDP, and then data would be the reg data, which is the data for the recession period, and we will use the ex0 figure. Okay, and the other for the SNN line plot for the non-recession period, so we will use non-reg data, which is the second one. Okay, we will add title for each one, Okay, so this is the GDP variation during recession period and GDP variation during non-recession period. You can see that at the recession period there is a decline in the GDP that decreased during the recession period, and in the GDP during the non-recession period they are increasing, and it can also go up during the recession period. So from this plot it's evident that during the recession the GDP of the country was in a low range, might have affected the overall sales of the company. Okay, the next plot we will develop a bubble plot for displaying the impact of seasonality on automobile sales. So we will use only the data for the recession periods. So we will use data for the seasonality weight, and this would be for the size of the bubbles. So we will do a scatter plot this time. Data equal non-reg data, which is this data, and will X for the month, Y for the automobile sales, and it will be differentiated by the seasonality weight. Okay, size equal the size of the seasonality weight. Okay, X label, Y label, as we discussed before. PLT title, plt.show. Okay, so this is the bubble plot, seasonality weight. Can see that this is the seasonality weight during the year. Can see that in there is a little bit raise in sales in the month of April. Can see that. So as overall the seasonality has not affected on the overall sales, so the seasonality has not that much effect on the automobile sales. Okay, so next plot we will use a Matplotlib to develop a scatter block to identify the correlation between the average vehicle price related to the sales volume during recession. Okay, so we will use a scatter plot, PLT to scatter, and this is the customer confident data, and with the automobile sale we will see if there is a correlation between these two columns or not. You can see that there is no any correlation, there is no any correlation between the automobile sales and the customer confidence that we can detect. Okay, also here we will plot another scatter plot and title it as also relation between the average vehicle price and sales during recession. Okay guys, so here also relationship between average vehicle price and sales during recession. During recession there is also no correlation between these two columns, so as we hear in the inference there is not much relation. Next plot we will do a pie chart to display a portion of advertising expenditure of XYZ automotives during recession and non-recession period. So here let me give you an idea about the pie chart. First we will aggregate the data. We will make data for the recession period and data for the non-recession period. Okay, so we will calculate the total advertising expenditure for both periods, RA total. For the recession, non-recession period, we will be the sum of the advertising expenditures for the NR data, non-recession period. Okay, so we will make a figure, and then we will label recession and non-recession. With size would be the RA total and NRI total, which are the sum of the advertising expenditure. Okay, So we will make a pie chart, plt.py size, which is the size of each one of these, and label, which be these labels that we mentioned before, and then we will do the annotation inside the pie chart, and we will start straight angle would be 90, that we will start from the 90 angle of the pie chart, and we will move clockwise. So let me show you the plot first. Okay, so here is the advertising expenditure. So start angle equal 90, that it would be a better to do that, to start from the 90-degree angle of the pie chart, and then to can move this way, and that would be a better way for the pie chart. Okay, so this is the recession and non-recession. 21% for the recession period, and for non-recession period there are 79, of course, percent. It's also higher than the expenditures in the recession period. So this is the one for the first figure, which is 21.1. So we will round it only for one digit. So let's say if we remove the 1 and make it like that, it will be like that. Okay, but when we add .1, it will round it to the nearest one digit, only one digit. Okay, will be like that. Okay, so it seems that the automotives has been spending much more than on the advertisement during non-recession period as compared to during recession times. Of course, fair enough. So we will develop also a pie chart to display the total advertisement expenditures for each vehicle type during recession period. Okay, so we will take a look about the data again. Okay, so we will do the filter the data. Okay, so df for get the recession periods only, and then calculate the sales volume by vehicle during the recession. So we'll RDA group by vehicle type, automobile sales dot sum. So we will sum the automobile sales according to the each vehicle type. Okay, so we will do the figure label. We will label it v extension dot index, which is we will take the index of the data frame after we did a group by function, or we applied the group by function on the data. Okay, so sizes would be v expenditures dot values. Okay, so size label and then the annotation, and then we'll straight angle equal 90. Okay, so let's okay, so in this pie chart we can see that the sports and the executive car has the lowest expenses, while the other cars in the recession period, like super mini cars and the medium family cars, the small family cars, are higher than these two types of vehicles. So during recession, the advertisement were mostly focused on low price range vehicle, and of course is a wise decision. Okay, so let's move on to the next graph. We will develop a line plot to analyze the effect of unemployment rate on vehicle type and sales during the recession period. So here we will do a line plot. Okay, data we will using, of course, Seaborn this time, not the Matplotlib. So X would be the unemployment rate, Y will be automobile sales, differentiated with the vehicle types. Style equal vehicle type. And then we will use style for the line. We will use markers for every period with like a 0 or O marker. Here style equal none. So we also use the ylim equal from 0 to 850, and also plt.legend. We will locate it at this position. I will show you, of course. So there is the line plot, and we can see that during the recession period, the there were the unemployment rate. Also, you can see that unemployment rate increased, and then the automobile sales you can see for each vehicle type. And here are the position of the legend. You can see that we determined the position of the legend to make the graph more visual. Let's see if we remove that. You can see that the legend appear at the middle of the graph, and that would not be so good for visualization, so we'll move it in a much better position. Okay, so in this graph, during recession, buying pattern changed. The sales of low range vehicle like super mini car and small family cars and mid mini car. Okay, so create, and here the last plot in this visualization project. Create a map of the highest sales region office of the company during the recession period. Okay guys, so we will give you an idea about how to do a map visualization. Okay, so first we will import request and import IO, and then we will use the request library to download the JSON file, which will contain the longitude and the data for each state of in the US. So file name would be US state JSON, and this would be a JSON file for the map data or geographical data for United States, okay, of America. So we will get the URL, and then we will raise an exception for bad status codes. This will do that for us, and then we will do a file, download a file, and then also do a new file and write in it the what's inside the JSON file, and then we will run this code, and then show file JS downloaded successful. Okay, so now we have the JSON file of the map of the United States, the geographical information for each state. Okay, so this is the code for how to do like a simple visualization map. So first we will filter the data, take only data for recession period, and then we will group by city and automobile sales. So something will group by city and automobile sales. So here we will create the main map, which is the United States map, and this is the data for the United States, which would be the main map for us, and we will zoom it for just only for we'll use it for 4. Okay, so let's show you the map of United States only without the rest of the code. Okay, so if we use this, okay, so this is the map of the United States. So we zoom it with 4. We can zoom it more. Let's say we need it for 5. Okay, so we will do it for 5. It will zoom more. Can see the map of the United States. Okay, so now after we get the main map, we will create a shortbread layer using volume, which will be the data that will be showed on the map. Okay, so the geographical data would be the US.json, the GeoJSON file with the state boundaries. So the geographical data of the state boundaries, to can use it to determine each data with to determine each state for or for every information in the data frame. Okay, so data equal sales by city. So this is the data frame. We will use columns city and automobile sales. So this is the columns that we will be using in the map. Key on, which is the feature.properties.name, which is the list that inside the JSON file or the US state is that is the name of the list that we will use it to get the information from the JSON file. So feature properties dot name. Okay, fill color would be, this is the color and the capacity of the color, and also line opacity. Okay, and the legend name, called the legend name automobile sales during recession, add to the main map. Okay, and here we will add and the name of the state, add the name of the state. So we will here we will add a child. We will add a child to another child to the main map. So volume feature to GeoJSON tooltip, we will add the name of the of each state. Okay, so let's try this code. Okay, so here we will see that automobile sales during the recession, there is the highest sales and this is the lowest sales, and we can see that the highest sales would be in California. This is the name, California, and in New York, and like in also Georgia, and you can see in Illinois, and but in other states they have like the lowest automobile sales, while the highest automobile sales is in California and New York. So this is like a simple map for to visualize data using the volume package to create a map. So if you need more information about how to do a map and to get the geographical data, just comment below, and also you will find the code of the this code down below at the description. So guys, thank you, and see you for the next video. Okay.